Hello, we are in Chapter 6, Section 6.5, Solving Quadratic Inequalities. In this video, we're gonna go over problem number 4, in which we are solving this inequality using test points. So when we're using test points, we first solve the corresponding equation, then plot the real solutions if there are any, write our intervals, choose test points, test them, and identify the solution set. So let's start with solving this quadratic equation in here. We know that it's always best to have the leading coefficient positive because then it's easier to factor. So let's isolate 0 on the left-hand side of our equation. So we'll add x squared to both sides and we'll subtract a from both sides. And that will lead to 0 equals x squared plus 2x and minus 8. Now we can factor that trinomial on the right-hand side as x plus 4 and x minus 2, because the 4 and negative 2 are numbers that multiply to negative 8 and add to 2 in here, still equals 0, and by the zero factor property, x plus 4 equals 0 or x minus 2 equals 0. The first equation, subtracting 4 from both sides, results in x equals negative 4, while in the second equation, if we add 2 to both sides, we get x equals 2. Those are our two x-intercepts. What matters, of course, is their alignment with each other on the x-axis. Negative 4 is further to the left, 2 is further to the right. So let's say negative 4 is somewhere here. Let's say 2 is somewhere there. And that partitions our real number line into intervals from negative infinity to negative 4, from negative 4 to 2, and from 2 to infinity. Now we choose our test points. Let's say to the left of negative 4, I will choose negative 6. Between negative 4 and 2, I will choose 0. And from 2 to the left, I will choose, say, 5. I now substitute those numbers into the original inequality to check if they result in a true statement or not. So starting with x equals negative 6, we get minus the quantity of negative 6 squared plus 8 less than 2 times negative 6, asking whether this is true or false. Now, the square of negative 6 is 36, but we externally multiply it by negative 1, and therefore it's negative 36, then plus 8, less than negative 12, which is 2 times negative 6. Is that true or false? Well, let's see. Negative 36 plus 8 is negative 28. Is this less than negative 12? Well, negative 28 is further to the left on the real number line than negative 12, so indeed it is less, and therefore this is a true statement. And since this test point satisfies our inequality, the whole interval from which it came, the interval from negative infinity to negative 4, is a part of our solution set. Let's move on to the test point of 0. All the terms with x will turn into 0, so we're just going to have 8 on the left-hand side, less than 0 on the right-hand side, asking whether it's true or false. Of course, 8 is not less than 0, so this is false. And therefore, this interval from negative 4 to 2, from which 0 came, does not belong to the solution set of our inequality. Finally, we have the test point of 5. On the left-hand side, it will be minus 5 squared plus 8, less than 2 times 5 on the right-hand side. Of course, we ask whether it's true or false. Now, 5 squared is 25, but we have that external factor of negative 1, so it's negative 25 plus 8, less than 10. We still ask the same question. Negative 25 plus 8 is negative 17. And negative 17 obviously is less than positive 10. So that's a check mark. And since this test point satisfies our inequality, the whole interval from which it came also does. Now we acknowledge that our inequality is sharp. It only has less than, there is no or equal part in it, and therefore the endpoints of our test intervals, that means the solutions to the corresponding equation, do not belong to that solution set. So I can simply mark them as open dots here to acknowledge they do not belong to the solution set. Therefore, our solution set is the union of those two intervals, from -infinity to -4 open, and from 2 open to infinity.